principal of $3,000 is invested at 7% compounded annually. What is the amount after 4 years? So we're going to count the years. And the $3,000 is going to grow by 7% each year. So we're going to take the previous cell, which is B4, and we're going to multiply it by 1.07. Or C4 rather. And then we continue the pattern. So to get this value, we multiply $3,210 by 107%. To get this value, we're going to multiply this by 1.07. And to get this value, we're going to multiply this by 1.07. So at the end of 4 years, we're going to have $3,932.39. Let's look at a different type of problem. So I could have calculated this using my calculator, taking $3,000 and I'm repeatedly multiplying it by 1.07. I'm multiplying it 4 times to be exact. Let's look at a different type of problem. 3 years from today, we want to have $5,000. A bank account pays 5% interest compounded annually. How much should we deposit today? So in this question, we know how much we want at the end, but we're trying to figure out how much we should start with. So we have this situation. So what we can do is actually work backwards. And so if I want $5,000 in year 3, then I need this much money in year 2. And so what I did is instead of multiplying, because I'm going backwards, I'm dividing. So I can take this and just pull it in this direction and continue the pattern. And so if I start off with this amount of money, in 3 years I will have $5,000. So we can check our answer to see if we're correct and do things the way we were doing them before. We could take that value. I'm going to round it to the nearest cent. And I'm going to multiply it by 105% over and over again until I get to year 3. And you'll see that I get very close to $5,000. The reason it's not exactly $5,000 is because these two numbers are not exact. But I've gotten close enough for an answer. So the answer to my question is $4,319.19. Now, I could have calculated that using the calculator, and so I could calculate this value using my calculator. It's repeated multiplication by 1.05, which is 105%, which is the rate, the factor by which that number grows each year, and it's over 3 years. And so I get that value. An amount of $10,000 is needed in 6 years. How much should be invested now at 3% to have that amount in 6 years? So we want 10,000 at the end, and we want to work backwards to today, which is 0, to find out how much we need to bring to the bank right now. So I'm going to take C9 and I'm going to divide it by 1.03 to figure out how much I need 5 years from now. If I continue the pattern, this is how much I need in 4 years. This is how much I need in 3, in 2, in 1, and today. So I've just divided by 103% 6 times to get this amount. So it makes sense that this number is smaller than 10,000 because it's going to grow to 10,000 in 6 years. So using our calculator, we're going to divide by that number 6 times. What principal should be invested today at 7% interest compounded monthly if you want to have $500 in 4 years? So we're talking about compounding interest monthly, and it's over 4 years. So we have 48 stages of increase. So we'll start at 0. I'm going to select these two numbers and then drag and let it repeat. So I've got from 0 to 48. I'm going to start at 5. So this is the starting value is going to be here, but we know that our final value has to be 500. So we're going to work backwards, and what we want to do is take that $500 in B51, and we're going to divide it by not 7%, but 7% divided by 12 because it's monthly. So if we put in $378.20 into the bank today, we go to the bank and deposit that much money, in 4 years we will have $500. Using our calculator,